Let us discuss characteristics of management of information systems. To begin with, a management of information system is a computerized database that collates, summarizes, and analyzes any type of information that is useful to a company's manager, such as finance, human resources, sales, inventory control, social media marketing. MIS monitors the company's performance in real time. MIS is also useful as managers can also use the information to gain insight. MIS is useful to automatically produce the reports. It is also helpful in decision making. So, all in all, if we consider all these important aspects of management of information systems, MIS are playing a vital role in any organization's performance. MIS for sales and marketing. MIS basically compiles and analyzes information about customers. Information is gathered from the customer receipts. Information can be aggregated to highlight buying trends and patterns, identify repeat and top purchasing customers as well, develop and fine tune its marketing strategy, resulting in lowered costs and increased sales department effectiveness. MIS for human resource management. It basically handles employee data such as basic personnel information, attendance and hours, performance review ratings, and payroll tracking, protecting privacy and maintaining the security. It also reduces the cost of keeping the paper records. MIS has basically important aspect with aggregated information. The system can provide patterns and trends as well. MIS is useful for improving recruiting efforts, administering benefits, and managing schedules and workflow. Management of information systems and information technology. IT section of a company has a dual role with management of information systems. It basically stores and analyzes data about the IT department. Role in acquisition, installation, and servicing of any MIS that the company adopts. MIS for accounting and finances. It is basically designed to restore and aggregate financial data used both internally by the managers and the chief financial officers and externally by the consultants and regulators, tax agencies, and others. Reports. Basically, report generation is one of the important aspects of MIS for management and accounting. Reports such as profit and loss statements, accounts receivable tracking, and other financial statements and balance sheets can easily be generated with the help of MIS with respect to accounting and finances. These are also responsible for enabling management and others to analyze the company's financial health. Corporations as well as governments are actually taking the advantage of MIS for finance and accounts. Also, capacity to maintain large databases, enabling organizations to store and organize and access financial information easily is again one of the important aspects of MIS for accounts and finance. These aspects are also used for accounting operations and generation of financial reports. These are again used to support budgetary planning and decision making processes. These systems are credited with increasing financial transparency, efficiency, and accountability. MIS for accounting and finances have one more leverage in the form of general ledger. General ledger is the core component of any organization. Use of MIS in finance is that it automatically updates all the transactions. It is also responsible for simultaneous updating of accounts such as sales, inventory, and accounts receivable, and also it reduces the errors as well. It also provides an accurate and permanent record of all historical transactions. MIS plays a vital role in cash management as well. Important uses of MIS in finance are basically highlighted. Controlling and monitoring and forecasting of cash is one of the important aspect of any management of information system. MIS in finance helps companies track the flow of cash through accounts receivable and accounts payable in an accurate manner. MIS extends a vital support for budget planning, evaluating what if scenarios. Then MIS serves as a decision making tool, helping in choosing appropriate financial goals. Financial reporting is also destined for MIS in accounts and finance. To generate multiple financial reports accurately and consistently, MIS are very essential entities. Internal reports as well as shareholder information takes less effort if we adopt MIS in accounts and finance. Compliance with the government regulations as well as auditing requirements are a hectic requirements of any organization, and these are easily dealt by MIS for accounts and finance. Next aspect that is covered by MIS for finance and accounts is financial modeling. Financial modeling basically sets the tune of the organization's financial growth. MIS in finances also enables organizations to store a large amount of data, helps managers to develop accurate models of external environments and thus incorporate realistic what if scenarios. Next point that we are going to look into is systems approach, and basically the systems approach can be categorized into the following entities. First and the foremost is management oriented, whether it is as per the requirements, whether it is future oriented, whether it is integrated, whether common data flows are highlighted, whether long-term planning is basically exercised, relevant connection of subsystem planning has been done or not, and simple databases. Further, it throws light upon relevance, accuracy, usefulness, timeliness, and completeness as well. 1.9, that is the next point for management of information system as a support to management. Basically, MIS extends a vital role and is a kingpin of any organization's financial and overall growth. MIS carries out the following tasks uh, such as planning, organizing, staffing, coordinating, directing, controlling. And these vital aspects, if they are taken care by the MIS, then the organization is bound to succeed. Further, MIS extends a vital support for the decision making activity. The decisions to be taken are as per the following scenario. First, let us focus on planning. Then decision is defined to be a selection from various alternatives, strategies, resources, methodology, and etc. Next step is organization, and the kind of a decision that is made over here is a selection of goals, people, resources, method, and authority. Next step that we come across in the MIS as a support to management is staffing, and the decisions that are being taken over here are providing a proper manpower complement. Next essential step in the MIS as a support to management is directing, and the decisions that are being taken over here are choosing a method from various methods of directing the efforts of the organization. Next step is coordinating, and the choice of the tools and the techniques for coordinating the efforts for optimum results are basically the decisions in this particular step. Further, if we look into the next step, it entitles for controlling activity, and the decisions are a selection of exceptional conditions and the decision guidelines. Next, we will talk about objective of any MIS. The first and the foremost objective is to provide information for decision support in the process of management, for the achievement of business goals in most efficient manner. MIS supports all levels of management in conducting the business operations. Now, if you look at the diagram, it covers the 5 to 6 major operations that are needed for any organization. MIS extends information supports to all the activities including planning, organizing, staffing, directing, coordinating, and controlling. And the uh, entities such as goal setting are easily carried out with the help of MIS as a support to management. The last point of chapter number 2, applications of MIS in various functional areas. And these functional areas are entitled to be marketing information systems, financial information systems, human resource information systems, production information systems. Functional information system is based on various business functions such as production, marketing, finance, and personnel, etc. These departments or functions are known as functional areas of business. Each functional area requires applications to perform all information processing related to the function. The popular functional areas of the business organizations are financial information system, marketing information systems, production marketing information systems, human resource information systems. Financial information systems is a subsystem of organizational management information system. This subsystem supports the decision-making process of financial functions at the level of an organization. Marketing information system. This subsystem of management information system provides information about various functions of the marketing system of an organization. Marketing is another functional area of the business organization which is engaged in marketing or selling of its products to its end users or customers. Important functions that a marketing process include the following: the marketing identification function, the purchase motivation function, the product adjustment function, the physical distribution function, the communication function, the transaction function, the post-transaction function. Production or manufacturing information system includes manufacturing or production information system provides information on production, operation activities of an organization and thus facilitates the decision making of production managers of an organization. The main decisions to be taken in the manufacturing systems are product design. Then comes machine control. Control is the action of a machine and the equipment. Production planning entitles deciding when and how many products should be produced. Facilities location decides where to locate the new production facilities. A typical manufacturing MIS is used to monitor the flow of materials and products throughout the organization. In a manufacturing process, raw materials or parts are transformed to finished products, and a manufacturing MIS is used at every stage. Human resource information systems include functional information system supports the functions of human resource management of an organization. The human resource management function, in its narrow sense, is also known as personnel management. The function involves manpower planning, staffing, training and development, performance evaluation, and separation activities. Let's talk about the next point, which says enhancing management decision making and decision support systems, understanding DSS, characteristic components, and major DSS applications. Enhancing management decision making. Now, see, there is a diagram which says intelligence is thrown upon design, which is again thrown upon choice, which is again thrown upon implementation. Identifying the problems occurring in the organization, intelligence indicates why, where, and what effect situation occurs. Intelligence activity requires to inform managers how well the organization is performing and let them know where the problem exists. This phase includes recognizing the problem, analyzing the problem. Recognizing the problem entitles before deciding anything, it is important to recognize what actually the problem is. Problem is the difference between something that is expected and the reality. Analyzing the problem. After identifying what the problem is, the decision makers must gather data and separate them from opinions. The design phase includes understanding the problem, generate the solutions, test the solutions for feasibility. This phase includes generating alternatives. A problem can be solved in many ways. If there is only one alternative, no decision is required. But for any rational decision making process, the manager should not jump on to work single proposal without considering all alternatives. Choice phase. This phase basically entitled for selecting an alternative action from those available to generate a quality information. This phase includes evaluating alternatives, choosing best alternative, which includes decision under risks, decisions under economic factor, decision under timing, and decision under limitation of resources. Implementation phase. It considers making chosen alternative work and continuing to monitor how well the solution is working. Decision support system. DSS helps the information system in intelligence phase where the objective is to identify the problem and then go to the design phase for solution. The choice of a selection criterion varies from problem to problem. It is therefore required to go through this phase again and again till satisfactory solution is found. In three-phase cycle, you may use either inquiry, analysis, and models as accounting systems to come to a rational solution. DSS helps in making a decision and also in its performance evaluation. DSS can be used to validate the decision by performing sensitivity analysis on various parameters of the problem. There are two types of decisions, programmable and non-programmable. Programmable decisions, because of its rule-based structure, can be computerized as inputs, process methodology, analysis, and choice of decision making are predetermined. DSS can be built around the rule in case of programmable decision making situation. In non-programmable decision, the rules are not fixed, predetermined, and requires every time the user to go through the decision cycle. DSS refers to the class of system which support in the process of decision making and does not always give a decision itself. The nature of the decision is such that the decision makers need a variety of information when same similar types decisions are to be made. Components of a decision support system. Primarily, transaction processing systems and external data have an impact on decision support system database. Then comes DSS software, then modules, OLAP tools, and data mining tools. Then comes user interface, and then finally the user is there for the interaction with this particular decision support system. Components of a DSS include database, software with models, data mining, and other analytical tools, as well as user interface. DSS database, it is a collection of current and historical data from a number of application or groups. It may be small database residing on a PC that contains a subset of corporate data that has been downloaded and possibly combined with the external data. Alternatively, DSS database may be a massive data warehouse that is continuously updated by major corporate transaction processing systems and data generated by website transaction. The data in DSS database are generally extracts or copies of production databases so that using the DSS does not interfere with the critical operation systems. DSS software system, it basically contains software tools that are used for data analysis, OLAP tools, data mining tools, analytical models that can be easily made accessible to DSS user. A model is an abstract representation that illustrates the components as relationships of a phenomenon. A model can be a physical model, a mathematical model, a verbal model. Sensitivity analysis model asks what ifs questions repeatedly to determine an impact on outcome of changes in one or more factors. What if analysis is basically working forward from known or assumed conditions and that allows user to vary certain values to test results to better predict outcomes if changes occur in those values. Examples: what happens if we raise the product price by 5%? What happens if we increase the advertising budget by 10,000? What happens if we keep the price and advertising budget the same? Desktop spreadsheets, MS Excel is often used for this purpose. Illustrative examples are online trading. Here are some of the transactions which are shown below, which basically explains the decision support systems and the 5 set of transactions that are basically performed for the purpose of understanding of the decision support system. The above list can be thought of as a database composed of transactions, records. The fields of each customer record are customer ID, region, payment method, source of a contact, product purchases, and time of the day. There is a great deal of information in the above transaction that could help managers answer important questions and make important decisions. Where do most of the customers come from? What form of payment is most common? Where do customers come from? How many customers come from each region? MS Excel offers many tools that are helpful in answering these kind of questions. Spreadsheet software has a very powerful tool called as pivot table that categorizes and summarizes data very quickly. Characteristic components of a decision support system are the database management, model management, knowledge management, user interface management. The database management, it comprises component that performs the function of storing and maintaining the information. The information comes from one or more sources: organizational information, external information, personal information. Model management component. A model represents an abstract representation and also illustrates the different components. A model can be physical, mathematical, verbal, business use models to represent variables and their relationship. DSS help in decision making by utilizing models. The model management system stores and maintains DSS models. Its function of model management is similar to the function of database management system. User interface management component. It enables users communication with DSS. It consists of UI management system. This is a component that enables combining of know-how, procedure with storage and processing capabilities of a computer. Knowledge management component provides information about relationship among data that is too complex for a database to represent. It consists of rules that can contain possible solutions as well as alternative solutions and methods for evaluating them. Major DSS applications are: DSS can be used in any knowledge domain. In fact, DSS are so widespread that people don't realize that they are using DSS. Spreadsheet is simple DSS that is very commonly used in many different situations. While using search engine, a DSS comes into picture for organizing huge amount of information in the form of text files, images and videos for easing users' decision making. Data visualization and geographic information systems. GIS support decisions that require knowledge about geographic distribution of people. Emergency response time can be easily calculated with GIS for governments. For installing branches, ATM's GIS extends support for identifying best locations. Applications of GIS in controlling crime. Web-based customer support systems help users to select products and services. Car purchases, computer purchases. DSS is IT industry. Example: EVM and STEER. With EVM, earned value management, one has to go through the WS work breakdown structure to break the project into small chunks and estimate each effort. SEER is an algorithmic project management software application designed specifically to estimate, plan and monitor the efforts and resources required for any type of software development or maintenance project. SEER is nothing but ability to foresee. Second chapter further leads us into interesting aspects such as executive support systems, role of executive support systems in organization, benefits of executive support systems. ESS, also known as EIS, supports and facilitates senior executives in decision making, provides easy access to internal as well as external information. It is specialized form of decision support system. ESS emphasizes graphical displays and easy to use interfaces. ESS offers strong reporting and drill down capabilities. ESS are enterprise wide ESS that help top level executives analyze, compare, and highlight trends in important variables so that they can monitor performance and identify opportunities and problems. In general, ESS is a reporting tool that allows turn organizations' data into useful summarized reports. These reports are generally used by executives for quick access to information from departments such as billing, costs, accounting, staffing, scheduling, and more. ESS also provides analysis tools that predict a series of performance outcomes over a period of time. This type of ESS is useful to executives as it provides possible outcomes and quick references, statistics, and numbers needed for decision making. Role of ESS in organization. Basically, providing executives an information in a readily accessible, interactive format using graphic-based queries on summarized and detailed data is the primary role of ESS in the organization. Used to analyze, compare, highlight, trains to help for strategic decision making in an organization is again the second most important role of ESS in the organization. ESS are integrated with operational systems, giving managers to drill down factual information of a problem, which is quite evident that the senior level managers can easily have the access to the operational data as well. ESS also ensures summary of an entire organization as well as EIS allows drilling down specific levels of details. Executives often face information overload and they must be able to separate chaff from the wheat in order to make the right decision. On the other hand, if the information they have is not detailed enough, they may not be able to make the best decision. An ESS can supply summarized information as per executive needs and yet provide opportunities to drill down to make details if necessary. ESS are able to link data from various sources, both internal and external, to provide amount and kind of data executives find useful. Now, let's focus on benefits of ESS. First and the foremost advantage or benefit of ESS is filtering of data for management. Further, it offers efficiency for decision makers. Next, it also improves inspection of information. It is also easier for executives to use his experience in the computer world with the help of ESS. ESS also has a role in providing timely delivery of the summary description of the company. Now, during this topic, we will discuss group decision support system, elements of group decision support system, characteristics of group decision support system, and finally, how JDSS can enhance group decision making. That will be our point of consideration during this entire discussion. DSS was basically entitled for managers. Group decision support system, that is GDSS, has a number of persons involved in the decision making process. IT supports such a decision making where there is a group participation, such as DSS is termed as group decision support systems. Like DSS, GDSS also has some components such as database, modules, DSS tools, which includes query, OLAP, spreadsheet, statistical analysis. Four configuration of group members are possible. Group members in one room operating on network with common display screen to share the display for all group members. GDSS process is transparent. Group members sit at their respective locations and use their desktop and LAN to interact with other members. GDSS process is not that transparent as in case of A. Group members are in different cities and they come together through teleconferencing, video conferencing with proper planning for GDSS operations. Group members are at remote locations, maybe in different countries as well, and they come together through long distance telecommunication network. In all the above four configurations, GDSS support software is available on the server for users to use it. Disregarding the configuration model of the group and the type of network they use, following activities are common: sending and receiving information in all forms, types across the network, display of notes, graphics, drawings, pictures, sharing ideas, choices, and indicating preferences, participating in decision-making process with inputs. In all combinations, group members work together in a collaborative manner. Collaborative work management tools support GDSS. Groupware software is used to accomplish a set of group activities. These GDSS tools help in calendaring, scheduling, project management, workflow, work group activities, and knowledge management. In GDSS, group members interact, debate, communicate, conclude using different tools and techniques. Elements of a GDSS. GDSS interactive computer-based system which help in solving various unstructured problems with the help of decision makers working in groups. Basic components of GDSS are hardware, which includes I/O devices, audio-visual instruments, electronic display board, oblique screens, computer equipments, conferencing infrastructure, network systems. Softwares in this part include database and database management systems, modeling capabilities, dialog management with multiple user access, specialized application programs to facilitate the group access, people and the procedures, trained facilitators, decision-making participants, and support staff. Facilitator is a person who directs the group through the planning process. Procedures refers to the methods that have been used in holding meetings. Characteristics of GDSS, which is a simple topic, and this can be asked for couple of times in examination. Goal of a GDSS is to improve the productivity of decision making meetings, either by speeding up the decision making process or improving the quality of the resulting decisions. This is accomplished by providing support for exchange of ideas, opinions, and preferences within the group, supporting parallel processing of information and idea generation by participants, enabling larger groups with more complete information, knowledge, and skills to participate in the same meeting, enabling several users to interact simultaneously, automatically recording all information that passes through the system for future analysis, helps in concentrating on the merits of info without considering about the fact who gave it, enables every group member to address the issue. Automated record keeping plays a critical support for future review and analysis. How GDSS can enhance group decision making. Purpose of GDSS is to help group of managers to solve unstructured, semi-structured problems. GDSS enhances group decision making by providing groups with the technology to collaboratively generate ideas, organize ideas, set priorities, resolve conflicts, and arrive at solutions. Destructive conflict miscommunication can be managed effectively through the use of GDSS. Originally designed to facilitate face-to-face meetings, GDSS technology is now widely used in virtual space. Improved pre-planning can be easily observed, increased participation, open or collaborative meetings atmosphere, criticism-free idea generation can be easily observed, documentation of meetings, setting priorities and making decisions. Improved pre-planning focuses an agenda to keep the meetings on track. Participation of more number of persons result into more effective contribution towards decisions. GDSS helps to provide open and collaborative meeting atmosphere which provide non-judgmental input by all attendees, GDSS provides criticism free idea generation with more inputs and better ideas. GDSS helps for effective documentation of meetings which are used for future discussion and use. GDSS helps to set the priorities and give importance to those problems which are more critical. Let's discuss information systems and the decision making activity. It withholds the typical points such as information system software, information needs at different organizational levels, major types of information systems in organization, and relationship between them. Enhancing management decision making is also one of the key aspects of this particular discussion. Let's talk about the first and the foremost point, which says information system software. Basically, hardware is considered to be a useless entity without a software. If we talk about the definition of a software, then we have to say it is a program needed to accomplish input, processing, output, storage, and control activities of information systems. The categories of software are, of course, system softwares and application softwares. System softwares are basically accountable to run a hardware and application programs. System software interfaces between hardware and the user applications. Second point discusses information needs at different organizational levels. If we classify information needs at different organizational levels, then there is a common thread, and the thread is type of decisions. Information can be classified as operational, tactical, and strategic informations based on that common thread, and that thread talks about types of decisions. Operational information will be the first set of classification category. Now it talks about day-to-day operations in an organization. Operational information are very useful in exercising control over repetitive operations. These repetitive activities are controlled at lower level, so operational information is needed by lower management. The typical examples of information that are required at the lower level are related to cash, related to attendance, etc. They are basically monitored on a day-to-day basis and controlled by lower level management. Further category of the information is tactical information. It basically helps middle level management, and it is typically entitled for allocation of resources. It establishes controls to implement top level planning. The examples of tactical information are information regarding the alternative sources of fund and their uses in the short run, opportunities for deployment of surplus funds in short-term securities. The next and the essential category in the information type is strategic information. It is basically needed for making choices among business options. It helps in identifying and evaluating business options so that managers make the informed decision and make the informed choices which are different from competitors. Now, this particular diagram explains the typical categories of informations or information needs at different organization levels in a proper manner, types of informations and levels of management. Now, the triangular part of the diagram explains levels of management, while the rectangular part of the diagram explains types of informations that are basically used. If you concentrate on the base of the triangle, it entitled for lower level management, and all the operational informations are basically required by this lower level management. Then comes the middle level management in the triangle, and it talks about the tactical information which is explained quite easily in this particular diagram. And the top one third of the triangle talks about the top level management, which ideally focuses on strategic informations. So this diagram particularly correlates the relationship between levels of management and the types of information that are being used. The typical curves are seen in this particular diagram, and these curves particularly say that operational information is not only required by the lower level management, but some aspects of operational information are essential for middle level management as well. And the curve that encompasses the middle and the top part of the rectangle explains the importance of tactical information to the top level managers as well. Although strategic information aspect covers most of the area in the upper rectangle. So with this we can have a proper understanding between levels of management and the types of information used. MIS is basically an important tool for managerial decision making. MIS is primary source of relevant and accurate and timely information to the management. Managers at different levels have different information needs due to the nature of the work. Proper dissemination of information at the various levels of management is very much required. There can be three levels of managerial decision making, and those are categorized as following: strategic decision making, tactical decision making, and operational decision making. Strategic decision making, these are the core activities which encompass establishing objectives of a whole organization and preparation of long-term plans for achieving these objectives. Strategic information is used for this strategic decision making by the top executives who have to take the decisions for the long-term benefits of the organization. Strategic information is a mixture of information gathered from both internal as well as external sources. The time scale may vary from 1 to few years or even longer depending on the project. Tactical decision making. It is required for implementation of decisions made at the strategic organizational level. So if you remember that middle part of our triangle, then you will easily understand the percolation of the decisions that are taken at the top level of the management have to be implemented by the tactical decision making activities. It takes place within guidelines set by the strategic plan. Tactical information is used by middle level management, and if we talk about the time scale, then it covers 1 to 6 months of decision and implementation. Operational decision making, it is basically entitled for executing specific tasks in an effective manner. Operational planning is based on the tactical plans. Lowest level of employee in the organization implements operational plans. Time scale is very short, such as on a daily basis, day-to-day basis, and on immediate basis. All three levels of managerial decision making exists mainly on two types of decisions: structured decisions and unstructured decisions. Now, if we talk about structured decisions, these structured decisions are considered to be repetitive, routine, and have a definite procedure for handling them. Structured decisions do not have to be treated each time as if they were new. A great proportion of structured decisions are at the operational level in the organization. Now, let's look at unstructured decisions. Decision makers must provide judgment, evaluation, and insight into the problem. As each of these decisions is novel, important, and non-routine, there is no definite and agreed upon procedure in advance for the decision making. Different levels of management decision making, types of decisions, and information characteristics at each level are summarized in the following slide. Now, please concentrate on this particular diagram. The triangle is being shown over here, and this triangle encompasses 4 different sorts of activities. If we consider from bottom to top, then we will look at different compartments, and they start from operations, then operational management, middle level management, and strategic management at the top. The diagram is bifurcated in 2 aspects: information characteristics at the left hand side and the decision structure at the right hand side. Now, if we talk about the information characteristics towards the top, then these characteristics are considered to be ad hoc, unscheduled, summarized, infrequent, forward oriented, external, and having a wide scope. And on the similar fashion, if we talk about the decision structure, then obviously it is seen unstructured decisions are prominently taken by the strategic management. Now, if you go a little downward, then you will come across information characteristics typically entitled to operational management, and these information characteristics are: first, pre-specified, scheduled, detailed, frequent, historical, internal, and having a narrow focus. On the contrary, the decision structure that is observed over here is structured sort of decisions. So if you look at the diagram from top to bottom, then you will descend from unstructured decisions to structured decisions on the decision structure parameter, and you will descend from ad hoc to pre-specified, unscheduled to scheduled, summarized to detailed, infrequent to frequent, forward oriented, historical, external to internal, wide scope to narrow scope on information characteristics parameter. Simultaneously, the strategic management descends into operational management if we go from top to bottom, and if we go from bottoms up, then operational management enters into strategic level, and this way this diagram can be easily understood in the form of this pyramid or a triangle with respect to information characteristics and the decision structure. Now this particular table explains the things that were easily visible on the earlier slide. Let us consider a few examples and understand the impact of this particular slide. So the table talks about important information characteristics at different levels of managerial decision making. So dependence on internal information. If this particular information characteristic is understood, then level of decision making with respect to this information characteristic can be very high at operational level, high at tactical level, moderate at strategic level. If we consider the next aspect, the last one particularly, use of predictive information. Now, level of decision making, if applied on this particular information characteristic, then operational level will have a low predictive use of information, tactical level will have a high use of predictive information, and strategic level will have a very high use of predictive information. So this way several information characteristics and level of decision making can be correlated, and the diagram that was evidently visible with the help of a triangle can be easily categorized into this particular table. So this let us focus on the next point of the second chapter, which says major types of information system in organization and relationship between them. The different types of information system that can be found are identified through a process of classification. Different kinds of systems found in organizations exist to deal with the particular problems and tasks that are found in organizations. Different types rely on the way in which tasks and responsibilities are divided within an organization, the way in which different classes of information systems are categorized tends to follow the hierarchy. This is often described as the pyramid model. Now, three-level pyramid based on the type of decisions taken at different levels in the organization. The bottom of the pyramid talks about the transaction processing system. The middle age of the pyramid talks about management information system, and the top level of the pyramid talks about executive information systems. Now, operational decisions correlate with the transaction processing systems, tactical decisions correlate with the management information systems, and strategic decisions correlate with executive information systems. So this way, if we talk in terms of bottom-up approach, then the operational information followed by tactical information followed by strategic information. And if we think in terms of top-down approach, then on the similar lines, strategic decisions are followed by tactical decisions are followed by operational decisions. So this way, this three-level pyramid classification of the information systems can be easily figured out. Similarly, by changing our criteria to the different types of data, information, knowledge that are processed at different levels in the organization, we can create a 5-level model. Now this 5-level model considers transaction processing system at the bottom of the pyramid, then comes office support systems, then comes management information systems, then comes decision support systems, then comes executive information systems. Now, tacit knowledge correlates with the executive information systems, explicit knowledge correlates with the decision support systems, information correlates with management information systems, and basic data correlates with transaction processing systems. The 5-level pyramid model is based on the processing requirements of different levels in the organizations. So, office support systems and decision support systems, these are typical two additional entities if we compare this particular diagram, this particular setup with earlier slide and earlier setup. Now, let us talk about the most common aspect, and which is called a 4-level model based on the people who use the system. It covers transaction processing system at the bottom, followed by management information system, then comes the evident aspect, decision support systems, and then comes executive information systems. Now, executives preferably and significantly correlate with executive information systems, senior management contribute in decision support systems, middle managers play a vital role in management information systems, and typical workers plays a vital role in transaction processing systems. So, in a nutshell, we can simply say this particular 4-level model is more used and is more significant into the organizations. 4-level pyramid model is based on different levels of hierarchy in the organization. The only aspect named DSS, decision support system, that is actually heredited from the earlier diagram, and it is basically descended from the earlier 5-level model, and the significance is very much vital. Decision support systems are evidently useful and widespread if we consider MIS and their impact in the organizations. Now, let's talk about the transaction processing system. These are the systems who are seen at the bottom of the pyramid. The transaction processing systems are operational level systems, and these are found at the bottom of the pyramid. They are usually operated directly by the shop floor workers or frontline staff, which provide the key data required to the support of the management. This data is usually obtained through automated or semi-automated tracking of low-level activities and basic transactions. Typical functions of a transaction processing system. TPS are ultimately little more than simple data processing systems. Functions of a transaction processing system in terms of data processing requirements is shown in the following table. The typical inputs for TPS are transactions and events. The things which need processing in transaction processing systems are validation, sorting, listing, merging, updating, and calculation. The typical outputs of the transaction processing systems are lists, detailed reports, action reports, summary reports. Some examples of transaction processing systems are payroll system, order processing systems, reservation systems, stock control systems, as well as systems for payment and funds transfer. The role of a transaction processing system: produce information for other systems, cross boundaries interactions, and these are typically used by operational level managers. These are also called as operational personnel and supervisory levels. These transaction processing systems are efficiency oriented. Now let's talk about the next level in the pyramid, named management information systems. MIS are built on the data provided by the transaction processing systems. For historical reasons, many of the different types of information systems found in commercial organizations are referred as MIS. However, within our pyramid model, MIS systems are the management level systems that are used by middle managers to help ensure the smooth running of the organization in short to medium term. The highly structured information provided by these systems allows managers to evaluate an organization's performance by comparing current with the previous outputs. Functions of MIS in terms of data processing requirements are listed out in the following table. Typical inputs for MIS are internal transactions, internal files, structured data. The processing in the form of sorting, merging, and summarizing is basically carried out by these MIS. Outputs, rather we should say typical outputs of MIS are summary reports, action reports, as well as detailed reports. Some examples of MIS are sales and management systems, inventory control systems, budgeting systems, management reporting systems, and personnel systems. These are also called as HRM systems. The role of MIS are quite evident, as we have seen that the transaction processing systems are the foundation of MIS. So let's talk about the roles that are played by MIS in detail. These are based on internal information flows, support relatively structured decisions. These are have little analytical capacity, used by lower and middle managerial levels. deals with the past and present rather than future, and these are efficiency oriented. Now let's talk about the next level of pyramid that we have seen in the initial slides, and that level is called as decision support system. We have seen that DSS were visible in the 5 level pyramid and in 4 level pyramid as well. So decision support systems are significant and have to be dealt properly while we are discussing that transaction processing systems, followed by MIS, and MIS are again giving foundational support to the decision support systems. Now let's see how these decision support systems are considered. A decision support system can be seen as knowledge based system used by senior managers. It facilitates the creation of knowledge and allows its integration into the organization. These systems are often used to analyze existing structured information and allow managers to project the potential effects of their decisions into the future. Such systems are usually interactive and are used to solve ill-structured problems. They offer access to databases, analytical tools, allow what-if simulations, and may support the exchange of information within the organization. If we consider the tabular data related to the decision support systems, then we have to look upon inputs of any decision support system. The first and the foremost input is internal transactions, the next comes internal files, and the next comes external information. Now, the activities such as modeling, simulation, analysis, summarizing are carried out during the processing of decision support systems. The typical outputs that are visible over here are summary reports, forecasts and graphs, as well as plots. Decision support system are group decision support systems, computer supported cooperative work CSCW, logistics systems, financial planning systems, spreadsheet models. The role of a decision support system: support ill-structured or semi-structured decisions, have analytical and or modeling capacity, used by more senior managerial levels, are concerned with predicting the future, as well as these are effectiveness oriented. Next, let's talk about the peak of the pyramid in the form of executive information systems. Executive information systems are strategic level information systems that are found at the top of the pyramid. They help executives and senior managers analyze environment in which the organization operates, to identify the long-term trends, and to plan appropriate courses of action. The information in such a systems is often weakly structured and comes from both internal and external sources. Executive information systems are designed to be operated directly by executives without the need of intermediaries and easily tailored to the preferences of the individuals using them. Functions of EIS are a bit easy, and these are: EIS organizes and presents data and information from both internal and external data sources and internal MIS or TPS in order to support and extend the inherent capabilities of a senior executives. Some examples of EIS are: executive information systems tend to be highly individualized and are often custom made for a particular client group. However, a number of off-the-shelf EIS packages do exist, and many enterprise-level systems offer customizable EIS module. The role of a EIS are explained with the help of following essential bullets. EIS are concerned with ease of use. EIS are concerned with predicting the future. EIS are effectiveness oriented. EIS are highly flexible. EIS support unstructured decisions. EIS use internal and external data sources. EIS are used only at the most senior management levels. If we Consider in a proper manner, then EIS has the inputs in the following form: external data, internal files, and predefined models. The processing activities that are carried out in EIS are summarizing, simulation, drilling down, and outputs that are evident in EIS are. Let us consider Unix operating system, chapter number 1. The name of the chapter is General Overview of the System. If you look at the contents, it has history, system structure, user perspective, operating system devices, and finally assumptions about the hardware. Let us understand the system structure. Here you will find a circular diagram where hardware is at the core, hardware is associated with the kernel, and then system programs exist around that kernel. Rather, kernel avails all the services to all these system programs, and finally in the outer layer you will find other application programs where user can create its own applications and this can be utilized for their own activities. Now hardware is at the center and it is known as basic services to the operating system. Operating system directly interacts with the hardware by providing common services to the programs as well as insulating programs from hardware. Operating system is called as kernel. With the help of system call programs in the outer layers interact with the kernel. System calls are actually the instructions to the kernel to various operations for calling program and exchanging the data between kernel and the program. The outermost layer contains application programs which are built on the top of the lower level programs. Examples are compiler, which actually invokes C preprocessor, 2-pass compiler, assembler, loader, and such kind of lower level programs. There are basically 64 system calls, but fewer than 32 are generally used. The kernel provides services upon which all the application programs in the Unix system rely, and it defines those services. User perspective. Now, this point entails high-level features of Unix operating system such as file system, processing environment, building block primitives. The file system of the Unix operating system is characterized by an anagram ADPTTH. A stands for ability to create and delete files, D stands for dynamic growth of files, P stands for protection of file data, then consistent treatment to the file data, treatment of the peripheral devices as files, hierarchical structure. All these features are very essential in Unix file system. Now here you will find a root at the core, and then files such as bean, etc, user are considered to be non-leaf nodes, and date.c and foo.c are considered to be leaf nodes. This is called as a sample file system tree. The file system is organized as a tree with a single root called a slash. Every non-leaf node is called as directory of files. Leaf mode is either directory, a regular file, or a device files. Path name is actually essential for locating the file in the file system. Path name is also called as sequence of components separated by a slash character. Examples of such path names are /etc/password, that is considered to be correct. /bin/root is also called as correct, but /etc/user/tty00 is nothing but a wrong interpretation. Programs in Unix have no knowledge of internal file format in which kernel stores file data, treating the data as an unformatted string of bytes. The syntax of accessing the data in a file is defined by system and is identical for all programs, but semantic of the data are imposed by the program. Data in the directory is treated as byte string, Directories are like regular files. Access permissions are associated with read, write, and execute for three classes of users. First is file owner, then file group, and everyone else, the world. Devices are treated as files. Special device files occupy node positions in the file system. Directory structure. Devices are protected with proper access permissions. Example: copy.c, new copy.c, copy, copy, new copy.dir contents, copy /dev /tty, terminal read, copy /dev /tty /dev/tty. Here you will come across a program where contents of a first file are copied into contents of a second file. Basically, these things are carried out with the help of set of system calls, and such a first system call is open. Then we have got a create system call, and then there's a system call called as copy. File descriptor is an entity that is returned on each of the system calls wisely open and create, while copy system call operates on the values in file descriptors fd old and fd new. And finally, during copy subroutine, the read system call is basically used, and the read system call contains three parameters: the file descriptor, the buffer, and size of the buffer. And operating on these three parameters, contents of older file or contents of first file are basically copied into the contents of second file. Now, let us talk about processing environment. Basically, a program is an executable file, while process is nothing but a program in execution. Many processes can execute simultaneously on Unix operating system. System calls allow processes to create new processes, terminate new processes, synchronize stages of process execution, control reaction to various events, and such a way these things are essential. Now let us talk about shell. System calls allow users to write complex programs, hence kernel doesn't contain many functions and facilities. Such functions are used as a lower level programs, example compiler and editor. Shell is nothing but a command interpreter program that users typically execute after logging into the system. Shell considers first word of the command line as command name. Shell forks and child executes the command associated with the name. It treats remaining words on command line as parameters to the command. Shell allows three types of commands: executable files, executable file containing sequence of shell command lines, internal shell command instead of exec files. Internal commands make a shell programming language in addition to a command interpreter, and provides commands for looping, conditional execution, case statement, change current directory. So this is a great value addition to the activities of shell. It can behave as a programming language. Shell syntax allows pattern matching and parameter processing. Shell is either executing commands synchronously or asynchronously. When it does it synchronously, then it waits for a command to terminate before reading next command line. And when it does it asynchronously, it reads the next command and executes it without waiting for prior command to terminate. Example: $wu synchronous and $wu and asynchronous. Every process executing in the Unix system has an execution environment that includes a current directory. Command cd is used to change this parent directory. Examples are cd/user/src/uts. Change the shell's current directory to the directory /user src and uts. cd // changes the shell's current directory to the directory that is 2 nodes closer to the root node. Double dot is a parent directory of the current directory. Shell is a user program and not as a part of kernel, so it is easy to modify it and tailor it to the particular environment. The system can execute various shells simultaneously. Users have the capability to execute many processes simultaneously. Processes can create other processes dynamically, synchronize process execution. These features provide users with a powerful execution environment. Now let us talk about building block primitives. The Unix system provides OS primitives. The operating system primitives enables users to write small modular programs that can be used as building blocks to build more complex programs. Two primitives are basically existing in the Unix environment. First is capability to redirect IO and second primitive is pipe. Capability to redirect IO. Processors conventionally have access to three files. They read from their standard input file, write to their standard output file, write error message to their standard error file. Examples are first ls. It is basically used for listing files in the current directory on the top of standard input. But the command line ls greater than output redirects the standard output to the file called as output. We have mail mjb less than letter opens the file letter for its standard input and mails its contents to the user named mjb. Processes can redirect input and output simultaneously. The command line nroff less than doc1 greater than doc1.out greater than errors is basically used for the text formatter nroff, which reads the input file doc1, redirects its standard output to the shell doc1.out, and redirects error message to the file error. 2 greater than means to redirect the output from file descriptor standard error. Pipe. Pipe is a system call or pipe is a building block primitive which is basically a mechanism that allows a stream of data to be passed between reader and writer processes. The processes can redirect their standard output to a pipe to be read by other processes that have redirected their standard input to come from the pipe. The program grep searches a set of files grep main a.c, b.c, c.c, where main is the pattern to be searched, a.c, b.c, and c.c are the parameters or set of files. Grep searches the three files a.c, b.c, c.c for the line containing the string main and prints the lines that it finds onto standard output. Sample outputs are given here. a.c main in bracket argc comma argv. c.c here is main loop. c.c contains main. Example program wc, that means word count, with option -1 counts the number of lines in the standard input file. The command line grep main a.c b.c c.c /wc -l counts the number of lines in the file that containing the string main. The output of the grep is piped directly into the wc command. Sample output is 3. The user pipes frequently makes it unnecessary to create the temporary files. The next point under consideration is operating system services. Now let us peep into what all different type of services that an operating system offers. First and the foremost service that an operating system avails is controlling the execution of processes by allowing their creation, termination, suspension, and communication. Scheduling processes fairly for execution on the CPU in a time-shared manner. Allocating main memory for an executing process. Secondary storage, swap device temporary movement, swapping system if entire process is moved to a swap device, paging system if pages of memory are written to the swap device. allocating secondary memory for efficient storage and retrieval of user data. This service constitutes the file system. It structures the file system in a well understood manner. It protects the user files from illegal accesses. It allows processes controlled access to the peripheral devices such as terminals, tape drives, disk drives, and network devices. The kernel provides its services transparently by hiding distinctions between the rig files and device files. It hides internal format of storage and returns unformatted byte stream. The kernel offers necessary services so that user level processes can support the services they must provide. Example, the kernel supports the services that the shell needs to act as a command interpreter. It also allows the shell to read terminal input, to spawn the processes dynamically, to synchronize the process execution, to create pipes, and to redirect input-output. So this way, 1.4 is done. Now let's peep into the next point of chapter number 1 of Unix operating system, and the point is assumptions about hardware. This bit basically constitutes interrupts and exceptions, processor execution levels, and memory management. All three subcontents are very essential as far as exam is concerned. Assumptions about hardware. Execution of a user processes, which includes user level and kernel level. When a process executes a system call, the execution of a mode of process changes from user to kernel. That is very much evident from this particular discussion. I would like to repeat it. When a process executes a system call, the execution mode of the process changes from user mode to kernel mode. Next, the difference between two modes are processes in user mode are able to access their own instructions and data, but not kernel instructions and data or those of other processes. Processes in kernel mode can access kernel and user addresses. The virtual address space of a process may be divided between addresses that are accessible only in the kernel mode and addresses that are accessible in either mode. Some machine instructions are privileged and result in an error when executed in the user mode. Example, machines may contain the instruction that manipulates the process status register. Processes executing in the user mode should not have this capability. The hardware views the processes in terms of kernel and the user mode and does not distinguish among the many users executing programs in those modes. The operating system keeps internal records to distinguish the many processes executing on the system. Kernel mode, user mode, and the processes are vertically lined up. Process A is in kernel mode, while process B is in user mode. Process C is in user mode, while process D is in kernel mode. Multiple processes and modes of execution can be understood with this slide. From figure that we have discussed in the earlier slide, we can come up with following conclusions. The kernel distinguishes between processes A, B, C, and D on the horizontal axis, and the hardware distinguishes the mode of execution on the vertical axis. System execute in one of the two modes. The kernel runs on behalf of a user process. The kernel is not a separate set of processes that run in parallel to the user processes, but it is a part of each other user process. The kernel refers to allocating resources or doing various operations. When shell reads the user terminal input via a system call, the kernel executing on behalf of the shell process controls the operating of the terminal and returns the typed character to the shell. The shell then executes in user mode, interprets the character stream typed by the user, and does the specified set of actions, which may require invocation of other system calls. Now, let us understand interrupts and exceptions. What is basically meant by interrupt? The Unix system allows devices such as IO peripherals or the system clock to interrupt the CPU asynchronously. On the receipt of the interrupt, the kernel saves its current context, determines the cause of the interrupt, and services the interrupt. After kernel services the interrupt, it restores its interrupted context and proceeds as if nothing had happened. The hardware usually prioritizes devices according to the order that interrupts should be handled. When the kernel services an interrupt, it blocks out lower priority interrupts but services higher priority interrupt. Now, with this particular diagram, you will understand typical interrupt levels. Now, at the right side of the diagram, you will find the priorities, and those can be listed out to be higher priorities and lower priorities. Machine errors, clock, disk, network devices, terminals, and software interrupts. These are constituting the left hand side of the diagram. Machine errors are at the top, while software interrupts are at the bottom. Exceptions. Likewise, we have exceptions as that of interrupts. An exception condition refers to unexpected events caused by a process, such as addressing illegal memory, executing privileged instruction, dividing by zero, etc. The Unix system use same mechanism to handle interrupts and exceptions conditions. Interrupts and exceptions, those can be compared as follows. Interrupts are caused by events that are external to the process, while exceptions happen in the middle of the execution of an instruction. Interrupts are considered to happen between the execution of two instructions and the system continues with the next instruction after servicing the interrupt. While exception, the system attempts to restart the instruction after handling the exception. Now, let us come to a point known as processor execution levels. The kernel must sometimes prevent the occurrence of interrupts during critical activity, which could result in corrupt data if interrupts were allowed. Example, the kernel may not want to receive a disk interrupt while manipulating a linked list because handling the interrupt could corrupt the pointers. Computers typically have a set of privileged instructions that set the processor execution level in the processor status word. Setting the processor execution level to certain values basically masks the interrupt from that lower level, allowing only higher level interrupts. If the kernel masks out disk's interrupts as per the diagram given below, all interrupts except clock interrupt and machine error interrupts are prevented. If it masks software interrupts, then all other interrupts may occur. Now let's understand memory management in a short. The kernel currently executing process permanently resides in main memory, that is RAM. When compiling a program, the compiler generates a set of addresses in the program that represent addresses of a variable and data structures or the addresses of the instructions such as functions. The compiler generates the addresses for a virtual machine as if no other program will execute simultaneously on the physical machine. When the program is to run on the machine, the kernel allocates space in main memory for it, but the virtual address generated by the compiler need not be identical to the physical addresses that they occupy in the machine. The kernel coordinates with the machine hardware to set up a virtual physical address translation that maps the compiler generated addresses to the physical machine addresses. Mapping depends on the capabilities of machine hardware and the parts of Unix system. Therefore, mapping machine dependent things becomes an important activity. Now, let us understand the next point called as Introduction to the Kernel, which entails architecture of the Unix operating system. Now, this diagram is very interesting, which is basically divided into three levels: hardware level, kernel level, and user level. In the hardware counterpart, you will come across different hardware components. And the kernel level, basically the important significant level in any operating system, is equipped with many such modules which are represented with the help of the blocks given in the kernel level, as we are able to see in the given diagram. The hardware control is a unit which works in association with the hardware down there in the hardware level. Now, this hardware control avails the services to the process control subsystem as well as file subsystem. File subsystem and process control subsystem are the two essential components of a kernel of Unix operating system. Process control subsystem, these block particularly considers three entities, and these are listed as inter-process communication, scheduler, which performs the scheduling activities, and then an activity of memory management. Now, file subsystem is working in association with a buffer cache, and buffer cache further interacts with the block character devices. Particularly, block devices are accessed through the buffer cache by the file system, while character devices are worked upon or associated directly by the file subsystem. Now, there are connections between this file system and hardware control, as well as process control subsystem and hardware control. These connections basically exemplify the relationship between file subsystem with the hardware through the hardware control unit, as well as relationship between or association between process control subsystem with the hardware through the hardware control. Now, file subsystem and process control subsystem, these two blocks of kernel are again working in association with each other, and these two modules or these two units are invoked via a system call interface. That is, file subsystem and process control subsystem both interact with each other. Now, system call interface is the topmost part of the kernel level that we were discussing at the initial part of our understanding. User level talks about the functionalities in connection with the system call interface, and this interaction happens either directly or through libraries. When it happens directly, then a use of trap instructions comes into picture, and when it occurs through libraries, then there is no such use of trap instructions. So this way, from bottom to top, this block diagram of the system kernel can be understood. It all starts with hardware at the bottom, then kernel level, which prominently comprises file subsystem and process control subsystem, and then at the top in the user level we have user programs which directly interact with the system call interface, or through libraries that interaction can happen. Two major components of the kernel are file subsystem and process control subsystem. The two entities, files and processes, are the two central concepts in Unix model. The basic illusion is that file system has places while processes have life. Figure shows various modules and their relationship to each other. Figure shows three levels: user level, kernel level, and hardware level. The system call and library interface represent the borders between the user and programs and the kernel. System calls look like ordinary function calls in C programs. Libraries basically map these function calls to primitive needed to enter into the operating system. Assembly language programs are basically used for invoking system calls directly without a system call library. Libraries are linked with the programs at compile time and are thus part of the user programs. The set of system calls are partitioned into two. Those interact with the file subsystem, and the system calls those interact with the process control subsystem. The file subsystem basically manages the files, allocating the file space and monitoring the free space, controlling the access to the files, and retrieving the data for the users. So these all essential functionalities of the file system are going to be seen through the entire syllabus of Unix operating system. The processes interact with the file subsystem via a specific set of system calls such as open, close, read, write, stat. Query the attributes of a file. Then we have chown, change the record of who owns the file, and chmod, change the access permissions of a file. The file subsystem accesses the file data using a buffering mechanism that regulates data flow between the kernel and the secondary storage devices. The buffering mechanism interacts with the block IO devices, drivers to initiate the data transfer to and from the kernel. Device drivers are kernel modules that control operation of a peripheral devices. Block IO devices are random access storage devices. Example, a tape driver may allow kernel to treat a tape unit as a random access storage device. The file subsystem also interacts directly with the raw IO device drivers without intervention of the buffering mechanism. The process control subsystem is responsible for four essential activities: process synchronization, inter-process communication, memory management, and process scheduling. All these activities, all these entities are core to any kernel in operating system. The file and the process control subsystem interact when loading a file into memory for execution. The process subsystem reads executable files into memory before executing them. Some of the system calls for controlling the processes are fork and exec. These are basically used for overlaying the image of a program onto a running process. Exit wait, these are used as synchronize process execution with the exit of a previously formatted processes. BRK, this is basically used for controlling the size of a memory allocated to a process. And signals controls the process response to extraordinary events. The memory management module basically controls the allocation of a memory. If at any time the system does not have enough physical memory for all processes, the kernel moves them between main memory and secondary memory so that all processes get a fair chance to execute, done by the swapper. The swapper process is sometimes called as a scheduler. It schedules the allocation of a memory for processes and influences the operation of the CPU scheduler. The scheduler module allocates the CPU processes. It schedules them to run in turn until they voluntarily relinquish the CPU while awaiting a resource or until the kernel preempts them. When their recent runtime exceeds time quantum, the scheduler then chooses the highest priority eligible process to run. The original process will run again when it is highest priority eligible process available. There are several forms of interprocess communication, ranging from asynchronous signaling of events to synchronous transmission of messages between the processes. The hardware control is responsible for handling interrupts and for communicating with the machine. Devices such as disks or terminals may interrupt the CPU while process is executing. If so, the kernel may resume execution of the interrupted process after servicing the interrupt. Interrupts are not serviced by special processes but by special functions in the kernel called in the context of currently running. The next point under consideration is introduction to the system concepts. The first ever point in this particular subbit is an overview of file subsystem. Next, we have processes. Processes are containing context of a process states, state transitions, sleep and wake up. Now, an overview of file subsystem. The internal representation of file is given by an inode. Inode is basically an identification of a file. Inode contains the description of the disk layout of the file data and other information such as file owner, access permissions, and access times. Every file has one inode, but a file may have several names, all of which map into the inode. Each name is called as a link. When processes refers to a file by name, the kernel parses the file name, one component at a time, checks that the process has permission to search directories in depth, and eventually retrieves the inode for that particular file. Example, if a process calls open fs2mjb.rge source file 1, the kernel retrieves the inode for the file fs2mjb.rge source file. When a process creates a new file, the kernel assigns it an unused inode. Inodes are stored in file system, but the kernel reads them into an encode inode table with manipulating files. The kernel contains two other data structures, the file table and the user file descriptor table. The file table is a global kernel data structure, but the user file descriptor table is allocated per process. When a process opens and creates a file, the kernel allocates entry from each table corresponding to the file's inode. File makes entries in the three structures: user file descriptor, file table, and inode table, maintains the state of the file and uses access to it. The file table keeps track of the byte offset in the file where the user's next read or write will start, and the access rights allowed to the opening process. The user file descriptor table identifies all open files for a process. The kernel returns a file descriptor for open and create system calls, which is an index into the user file descriptor table. When executing read and write system calls, the kernel uses file descriptor to access the file descriptor table, follows a pointer to the file table and inode table. From the inode, finds the data in the table. File system layout is given here. File descriptors, file table, and inode are shown in this particular diagram. There are links from user file descriptor table to the file table and from file table to the inode table. System keeps regular files and directories on block devices such as tape or disks, which is very evident if we learn Unix operating system and its kernel. The block devices have several physical disk units, such as containing one or more file systems. Partitioning a disk into several file systems makes it easier for administrator to manage the data stored there. The kernel deals on logical level file system with the file system rather than with the disks at physical level. Logical device is identified by logical device number. The conversion between logical device addresses and physical device addresses is done by the disk driver. The file system consists of sequence of logical blocks, each containing 512, 1024, 2048, or any convenient multiples of 512 bytes. The size of a logical block is homogeneous within a file system. Use of a large logical blocks increases the effective data transfer rate between the disk and the memory, which in turn speeds up The operations. The kernel can transfer more data per disk operation and therefore make fewer time-consuming operations. However, if a logical block is too large, effective storage capacity may drop. A file system structure. A file system has the following structure. Boot block contains the bootstrap code that is read into a machine or a boot or initialize. Superblock. It describes the state of the file system, how large it is, how many files it can store, where to find free space on the file system, and other information. Inode list is nothing but a list of inodes that follows the superblock in the file system. Administrator specifies the size of inode list width when configuring file system. The kernel references the inodes by index into the inode list. One inode is the root inode of the file system. Data block contains file system data and administrative data. With the help of this particular slide, we can have an overview of a file system layout. Boot block, super block, inode list, data blocks, file system layout. Overview of the process control subsystem. It describes the structure of the process and process data structure used in memory management. View of the process state transition diagram and state transitions. Structure of the process. A process is a execution of a program. Process consists of pattern of bytes that the CPU interprets as machine instructions called as text, data, and stack. Many processes appear to execute simultaneously as the kernel schedules them for execution. Several processes may be instances of one program. A process may read and write its data and stack sections, but it cannot read or write the data and the stack other processes. Process communicate with other processes via system calls. A process on a Unix system is an entity that is created by the fork system call. The process that invokes the fork system call is the parent process, and newly created process is the child process. The kernel identifies each process by its process number, called as the PID or process ID. Executable file consists of several parts. A set of headers that describe the attributes of the file, the program text, a machine language representation of data that has initial values when the program starts execution, and an indication of how much space the kernel should allocate for utilization of the data, VSS. Other sections such as symbol table information. The kernel loads an executable file into memory during an exec system call, and the loading process consists of at least three parts called regions, text, and data and stack. The text and data regions corresponds to text and data BSS block stared by symbols, sections of the executable file, but the stack region is automatically created and its size is dynamically adjusted by the kernel at a time. The stack consists of logical stack frames that are pushed when calling a function and popped when returning. A special register called a stack pointer indicates the current stack path. A stack frame consists of parameters to a function, a local variable, and the data necessary to recover the previous stack frame, including the values of the program counter and stack pointer at the time of the function call. With the help of this particular slide, you will come to know the importance of command line arguments, file descriptors, and parameters and variables appearing on the stack when copy is called. A process is in the Unix system can execute in two modes, kernel mode or user mode. Therefore, it uses separate stack of each mode. The user stack contains the arguments, local variables, and other data for functions executing in the user mode. The kernel stack contains the stack frames and others. With the help of this diagram, you will come to know the impact of user stack and kernel stack and how the operations are carried out in the Unix operating system. Every process has an entry in the kernel process table, and each process is allocated a U area, contains a private data manipulated only by the kernel. The process table contains or points to a per process region table whose entries point to entries in region table. The region is a contiguous area of a process interspace such as text, data, and stack. Region table entries describe the attributes of the region, such as whether it contains text or data, whether it is shared or private, and where the data of the region is located in memory. The extra level of indirection allows independent processes to share regions. When process invokes an exec system call, the kernel allocates regions for its text, data, and stack after filling the old regions the process had been using. When a process invokes the fork, the kernel duplicates the address space of the old process, allowing processes to share regions when possible and making a physical copy otherwise. Process data structures. Now, here in this diagram, you will come across UArea, process table, per process region table, and main memory. Relevant data structures for running a process. The process table points to a per process region table with pointers to the region table entries for text, data, and stack regions of the process. The process table entry and the U area contain control and status information about the process. The U area is an extension of the process table entry. The fields in the process table are a state field, identifiers indicating the user who owns the process UID, an event descriptor set when process is suspended in the sleep state. The U area contains information describing the process that needs to be accessible only when the process is executing. The important fields of the U area are a pointer to the process table slot of the currently executing process, parameters of the current system calls, return values and error codes, file descriptors for all open files, internal IO parameters, current directory and current root, process and file size limits. The kernel can directly access the fields of the U area of the executing process but not of the U area of the other process. Internally, the kernel references the structure variable U to access the U area of the currently running process. When another process executes, the kernel rearranges its virtual address space so that structure U refers to the U area of the new process. 1.7.2.1. The next point is context of a process. The context of a process is its state, the values of the global variables and the data structures, the values of the machine registers it uses, the values stored in its process table slot in U area, and the contents of its user and kernel stack. When executing a process, the system is said to be executing in the context of that particular process. When the kernel decides that it should execute another process, it does a context switch so that system executes in context of the other process. The kernel allows context switch only under specific conditions. When doing when doing when doing a context switch, the kernel saves enough information so that it can later resume its execution. Similarly, when moving from user to kernel mode, the kernel saves enough information so that it later returns to user mode and continues execution from where it left off. Moving between user mode and kernel mode is a change. Here, the kernel does a context switch when kernel changes context from process A to process B. It also changes execution mode from user to kernel, from a kernel to user, still executing in the context of one process, such as process A. The kernel service interrupts in the context of the interrupted process, even though it may not have caused the interrupt. The interrupted process may have been executing in user mode or in kernel mode. The kernel saves enough information so that it can later resume execution of interrupted process and services interrupt in kernel mode. Process takes. The lifetime of a process can be divided into set of steps, each with certain characteristic that describes the process. The process is currently executing in the user mode. Process is currently executing in kernel mode. The process is not executing but it is ready to run as soon as the scheduler chooses it. Many processes may be in this state and scheduling algorithm determines which one will execute next. The process is sleeping. A process puts itself to sleep when it can no longer continue executing, such as when it is waiting for IO to complete. A processor can execute only one process at a time. At most, one process may be in state 1 and state 2. Process state and state transition. A state transition diagram is a directed graph where nodes represent the states of the process can enter and whose edges represent the events that cause a process to move from one state to other state. Depending on the event, the process moves from one state to another state. Several processes can execute simultaneously in a time-shared manner. They may all run simultaneously in the kernel mode. If the process is allowed to run in kernel mode without constraints, they should corrupt global data structures. The kernel protects its consistency by prohibiting arbitrary context switches and controlling the occurrence of interrupts. The kernel allows context switch only when a process moves from the kernel running to the state asleep in the memory. The processes running in kernel mode cannot be preempted by the other processes. Therefore, the kernel is sometimes said to be a non-preemptive, although the system does prompt processes that are in user mode. The kernel maintains consistency of its data structures because it is non-preemptive, thereby solving the mutual exclusion problem, making sure that critical sections of the code are executed at most one process at a time. Context switch can be done in the kernel state only if the system and data structure is in safe and consistent state. Now, if you look at the diagram, the states 1, 2, 3, 4 are given here. Ready to run is our state number 3, and from that 3 to kernel running, this 3 to 2 transaction happens when a process is scheduled. A transaction from 2 to 4 happens when a process is asleep, and 4 to 3 transaction happens when a process wakes up. Now 1 to 2 and 2 to 1, these transactions happen when there is a provision of a system call. With the help of the diagram, these points can be easily justified. Sleep and wake up. Processes go to sleep because they are waiting and the occurrence of some event, such as waiting for IO completion from peripheral device, waiting for a process to execute, waiting for the system resource to become available. Processes are set to sleep on an event, meaning that they are in the sleep state until event occurs, at which time they wake up and enter the state ready to run. Many processes can simultaneously sleep on an event. When an event occurs, all processes sleeping on the event wake up because the event condition is no longer true. When process wakes up, it follows the state transition from the sleep state to the ready to run state. After that, processes are scheduled by the scheduler. Sleeping processes do not consume CPU resources. The kernel does not constantly check to see that a process is still sleeping but waits for the event to occur and awakens the process then. Example, a process executing in the kernel mode must lock the data structure in case it goes to sleep. Processes attempting to manipulate the locked structure must check the lock and sleep if another process owns the lock. The kernel implements such a lock in the following manner. While condition is true, sleep event condition becomes false, set condition true. It unlocks the lock and awakens all processes asleep on the lock in the following manner. Set condition false, wake up, event condition false. With the help of this multiple processes sleeping on a lock diagram, we can understand the competition in between the several processes for the resource. Now, the figure is actually depicting the following scenarios. The sleep condition is that the buffer is locked. The process execute one at a time, find the buffer locked, and sleep on the event that buffer becomes unlocked. Eventually, the buffer is unlocked, and all the processes wake up and enters the state ready to run. The kernel eventually chooses one process, say process B, to execute. The process B executed the while loop, find that the buffer is unlocked, sets the buffer lock, and proceeds. If the process B later goes to the sleep again before unlocking the buffer, waiting for completion of an IO operation. For example, the kernel can be scheduled for other processes to run. If it chooses process A executes the while loop, finds the buffer is locked, and process A goes to sleep again. Process C may do the same thing. Eventually, process B awakens and unlocks the buffer, allowing either process A or C to gain the access to the buffer. Thus, the while sleep loop ensures that at most one process can gain access to that particular source. Now, here we will understand different kernel data structures. The kernel data structures occupy fixed size tables rather than dynamically allocated spaces. Advantage of this approach are kernel code is simple and limits the number of entries for a data structure. These number of entries equal to number that was originally configured when generating the system. On the other hand, if a kernel is configured so that it is unlikely to run out of the table space, the extra table space may be wasted because it cannot be used for the other processes. Kernel algorithms typically use simple loops to find free table entries. This method can be easier to understand, more efficient than more complicated allocation schemes. Now, we'll end the chapter with the help of the system administration concepts. Administrative processes do various functions for the general welfare of the user community. Functions like disk formatting, creation of a new file systems, repair of a damaged file systems, kernel debugging. There is no difference between admin processes and user processes. They call the same set of system calls available to the general community. Now, they are distinguished from general user processes only in rights and privileges they are allowed. Example, file permission modes may allow administrative processes to manipulate files. Internally, the kernel distinguishes special user called a super user with special privileges for admin processes. A user may become a super user by going through a login password sequence or by executing a special program. So with this chapter ends here.